हे एवरीवन, हेलो मेरे फ्यूचर डॉक्टर्स एंड इंजीनियर्स। चलो आज ना एकदम सुपर फास्ट तरीके से मोशन इन अ स्ट्रेट लाइन चैप्टर को खत्म करते हैं। रेडी हो जाओ।
So, challenge accepted? Of course it is. 5 मिनट में पूरा चैप्टर, सारे important concepts. I'm telling you, let's make every single second count. पूरा फोकस स्क्रीन पर रखो, इधर-उधर नहीं।
ओके तो अगर आप इस रैपिड फायर रिवीजन के लिए एकदम रेडी हो तो फटाफट से लाइक बटन दबा दो। चलिए, let's dive right in. Alright, to understand motion, we've got to get 3 basic things crystal clear first. An object's position, the distance it's covered, and what its displacement is. सोचो, ये इस chapter की ना ABCD हैं, the absolute basics.
This is probably the most common question, right? And trust me, getting this concept clear is super, super important. I mean, they sound almost the same, but in physics, nope, they're totally different.
You know, the key difference is actually pretty simple. Path length, or distance, is the actual road you took, the total journey. It's a scalar, so it's always positive. But displacement, that's the shortcut, a straight line from your start to your finish. It's a vector, which means direction matters, and it can be positive, negative, or even zero. Big difference. Okay, so now that we know where an object is and how far it's gone, let's talk about, well, how fast it's going. And for that, we're going to need 3 new friends: speed, velocity, and acceleration. Here we go, another classic point of confusion. Let's say a car goes around a racetrack and comes right back to the starting line. What's its average speed? And more importantly, what's its average velocity? Think about it. And here's the answer. This is the core difference. See, average speed uses the total path length, the entire track. But average velocity? It only cares about displacement. So remember that race car? Since it came back to the start, its displacement is 0, which means its average velocity is also 0, even if it was going at 300 kilometers per hour. Crazy, right? So average velocity tells you the story of the whole trip. But what if I want to know the velocity at exactly 2 seconds for that specific moment? Well, that's where instantaneous velocity comes in. It's just like your car's speedometer. It tells you your speed at that very instant. And in the language of calculus, we just call it the rate of change of position, or dx by dt. Great. So we've got position, speed, velocity, all figured out. But what happens when the velocity itself is changing? You know, when a car starts a race, or when you hit the brakes? That's when acceleration enters the picture. It's actually very simple. Acceleration is just the rate at which velocity changes. If the velocity is increasing, that's positive acceleration. If it's decreasing, that's negative acceleration, which we also call retardation. And in calculus terms, it's just dv by dt. See? Simple. All right, numbers and formulas are great, but you know the best way to really feel the motion? It's graphs. Graphs literally show you the entire movie of the object's journey. We have position time, velocity time, acceleration time. They're all important. For instance, the slope of an xt graph gives you velocity. But let me tell you, for NEET and JEE, most of the questions come from the velocity time graph, the VT graph. Why? Because a single VT graph tells you 2 of the most important things you need to know. So here's your first hot tip. The slope of a VT graph, you know, how steep the line is, that directly gives you the acceleration. The steeper the line, the greater the acceleration. And if it's a straight line, that means constant acceleration. Easy peasy. And now for the second super hit tip. The area under that VT graph, that gives you the total displacement for that time period. Just calculate the area under the curve and bam, you've got displacement. Seriously, note these 2 points down. They're absolute gold. Okay, now it's time for the Brahmastra of this chapter, the ultimate weapons. If the acceleration in a motion problem is constant, you don't need to mess with calculus or graphs every time. Instead, we have 3 golden equations. These right here, these are the 3 golden equations that you should know even in your sleep, where v is final velocity, u is initial, a is acceleration, t is time, and s is displacement. With these, you can solve literally any problem that has constant acceleration. Now, we call them the equations of motion, but they didn't just fall out of the sky. There's a very simple logic behind them. Let's take a quick look at the first one and see where it actually comes from. The logic is so simple you'll love it. What's the definition of acceleration? It's the change in velocity over time. So the formula is A equals v minus u divided by t, right? Now, just rearrange it. Multiply t over to the other side, so you get a times t equals v minus u. And there it is, your first equation, v equals u plus at. It comes straight from the definition of acceleration. All right, one last concept, but it's a really important one. Motion is never absolute. It's always relative. What that means is motion depends entirely on who is watching it. The best example for this is always a train. Imagine you're on a train, and another train on the next track is moving at the exact same speed in the same direction. To you, that other train will look like it's not moving at all. That's relative velocity. And the math is simple. The velocity of object A relative to B is just VA minus VB. Remember the rule. Same direction, you subtract. Opposite direction, you add.
So there you have it. We've touched upon all the core concepts, the formulas, the graph tricks of this chapter. The concepts are clear, you have the tools. So, are you feeling more confident now? Okay, let's do a final super quick recap. Get ready to take a screenshot of this slide. These are the 5 most important takeaways from this chapter. The slope of a VT graph gives you acceleration. The area under it gives you displacement. And of course, the 3 golden equations of motion. That is literally your entire chapter summarized on one single slide.
I really hope this rapid revision was helpful for you. If it was, definitely hit that like button and subscribe for more quick revision explainers just like this one. Keep practicing. And hey, here's a thought to leave you with. If all motion is relative, does absolute rest even exist? Think about it. All the very best.